Thanks, James. Okay, we've made it to the end of the day. I hope you still have a little bit of energy left. You've recharged your caffeine downstairs if you've needed to. I have been told that I have a very calming voice. So if you haven't recharged your caffeine, I may actually put you to sleep, and for that, you're welcome, or I'm sorry. I am a vice president of engineering at a startup called Astrum. We are helping early career recruiting, not just for tech, very broadly. This talk is about organization and architecture, and I'm going to cover not only the things that we're doing at my current company, but at my last several companies, some of the lessons I've learned on the interaction between organization and architecture. And whenever you talk about this subject, you always have to start with Conway's Law. How many of you have heard of Conway's Law? A pretty good percentage. For those who haven't, I will talk about it. For those of you who are aware of it, I will probably tell you things about it you don't know. So you'll learn, but it's really just a stepping off point for this discussion. So for those who aren't aware, Conway's Law comes from an article that Melvin Conway wrote in Datamation magazine over 50 years ago. So Datamation magazine, computer industry magazine, he was a software architect at the time in a company where software architecture not only was a discipline, but where there was an entire organization dedicated only to software architecture. They would design it and then hand it off to other teams to implement. Our original article, by the way, Mel Conway, one of the cool things, Mel Conway's still alive. He has a website. You can download this article from his website. It is 4 pages long. It's a pretty quick read, and it's worth reading because you get a lot of nuggets that you don't get if you're just familiar with what is called Conway's Law. And this is what people tend to think of. This is a quote from his article. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. That is Conway's Law. The term, by the way, for Conway's Law came from a book called The Mythical Man Month. How many people know that book? Yeah, Fred Brooks' book, another sort of classic text of our industry. He's the one who coined that term in that book. So a simpler version of this is sort of my simplification. Any piece of software reflects the organizational structure that produced it. I actually like Eric Raymond's restatement. If you have 4 groups working on a compiler, you'll get a 4-pass compiler. And also Cheatham's amendment to Conway's Law, which is if a group of n persons implements a COBOL compiler, there'll be n-1 passes because someone in the group has to be the manager. The idea is just generally this. Conway, by the way, again, he was talking about the architecture organization. He wasn't even talking about the people implementing the code. He was just talking about the people architecting the code. And this was 50 years ago, but it's still true. This is why we still talk about it. And practically what it means is when I see an architecture like this, which is a fairly clear and obvious architecture, I can be about 90% sure that I'm going to see an organizational structure that looks pretty much like this, because these things just tend to happen. If I didn't see this architectural or this organization given that architecture, I'd be a little bit surprised, honestly, because it's a fairly obvious way to organize your teams if you have that architecture. The thing is, though, he wrote this 50 years ago, we write software completely differently now. Why is it that Conway's Law still applies? Why is it that we still talk about it? There's not a lot of stuff in computer science that we talk about that's 50 years old anymore, and refer back to the original text. The thing is that he calls this out in the article. He was looking for reasons why this kind of correspondence happens. He talks about something called the homomorphic force. And he says, speaking as a mathematician might, we would say that there's a homomorphism from a linear graph of a system to the linear graph of its design architecture. The homomorphism, the actual definition of homomorphism in math is this. It's a mapping. It's a mapping between two structures, right? He's talking about it in these kind of academic and scientific terms, but one thing that's also important to understand about the original paper, it was in Datamation magazine, is like kind of like Wired at the time. He actually did submit this paper to Harvard Business Review, try and be more academic, and they rejected it because they said he hadn't proven his thesis well enough to reach academic rigor. And this article, when you read the 4-page thing, it kind of reads actually a little bit, it is essentially a 1968 blog post. And in fact, it's kind of a 1968 blog post from a bit of a grumpy developer. And I'll actually show you a little bit more about that later in the talk. But this homomorphism idea, this is the kind of why he believes you end up with this correspondence in the structures. And I was talking, when I first wrote this talk, I was talking to Britt Andreatta, and she is somebody who studies brain science in the context of organizations and in the context of companies. And so she's not really from software. And I told her about Conway's law, and she struck upon something I hadn't really thought about before. She pointed me at a part of your brain that's in the hippocampus called the entorhinal complex. The entorhinal complex in your brain is the part of your brain that stores maps. It's the part of your brain that tells you when you need to go to the bathroom where it is, right? It's the part of your brain that tells you when you need to get home tonight, how to get to the subway. It's also the part of your brain that tells you the social structures that you're part of. It maps your social structures as well. It tells you how you're related to people. It remembers those elements, those structures. And it remembers the structures of your software. All these things are stored in the entorhinal complex. And it wants to find correspondences. It wants to find things that make its job and your job easier. And a real practical example of this, my previous company, we were spread on 6 floors of a building. On 5 of those floors, the kitchen was in the exact same place because we'd done the remodeling on those floors. On the 6th floor, we'd taken it over from another company. They'd put the kitchen in a different place. Every time I was on that floor, because I didn't work on that floor, and I wanted a cup of coffee, I walked into the wrong place because I just assumed it was where it was on everything else. And even though I'd done that many times, I kept doing it because my brain wanted it to be in the same place as on every other floor. That's my entorhinal complex. So your entorhinal complex is looking for patterns. It's looking for homomorphisms. And this means when you talk about Conway's law, there's a part of your brain that really wants Conway's law to be true. And that's part of how we get there. If you think about it in the context of your architecture and your company, right? If you found a bug, let's say your company produces multiple platform apps, and you find a bug in the iOS app, and you don't really know the structure of the organization, you're from finance or something, and you say, oh, I found a bug in the, but you know a little bit about the architecture. You say, oh, I found a bug in the iOS app, who should I talk to? And somebody says, oh, you should talk to the infrastructure team because they actually own that part of the iOS app. You'd say, what? Why would I talk to the infrastructure team about an iOS bug, right? Similarly, if you were looking for something, you talk to the iOS team and you'd say, oh yeah, I really am curious about how this works in the API, who should I talk to? And they say, oh, you should talk to the Android team because they own the API. You'd say, wait, don't we have a service team? Like, why wouldn't the service team own the API? You'd be really confused. That's your entorhinal complex being unhappy, essentially. So I'll talk about Spotify in a minute. So interestingly, because anecdotally, Conway's law has remained true 50 years later, Harvard, amongst other places, the place that rejected his paper originally, went and studied it about 10 years ago, so 40 years after he wrote the paper. And they were looking for actual academic proof of this. The team that did it wrote a paper published in HBS, or HBR, that called this the mirroring hypothesis. So homomorphic force mirroring hypothesis, very similar. And they talked to hundreds of companies looking for this, and they found it. They found fairly good evidence that this was the case. And again, one of the things that they call out is that in an organizational structure, the organization structure kind of dictates who you talk to and who you spend a lot of time with. And when you spend a lot of time with your group and you're not really talking to people from other groups, those social relationships tend to actually be reflected in your architecture. And it's very easy, again, to just thought experiment. Let's say you go back to work on Monday and they say, congratulations, you've learned so much at Full Stack Toronto that we're going to give you a brand new project that you're going to own and you're going to prototype and build the initial version of. So you go, awesome, this is great. So you start thinking about it and you design your sort of initial architecture. You start building it by yourself because you can do that, and it starts to grow. And then eventually it's grown big enough that you say, you know what, actually I need help with this. I can't do it all by myself anymore. And they say, awesome, it's looking great. So here's somebody else to help you. And now it's just two of you working and you're working very closely together. So you have the architecture fairly much consistent in both your heads. But now it's starting to get a little bit painful because you're kind of stepping on each other's check-ins. So you say, okay, well, you know what, you're better at the sort of data layer and I'm better at the sort of API layer. So why don't you focus on that and I'll focus on this? And you kind of build a little sort of little wall between your concerns. And that's going fine, but now like their check-ins are breaking yours and your check-ins are breaking them. And you say, you know what, actually it'd just be easier for us to make an interface. Like you're working on this, I'm working on this, we'll put an interface between these, so then we just have to make sure the interface is good. And over time, those become different services possibly. And very obviously, now you're not really talking to each other about what's going on behind the interfaces, the architecture will start to diverge. And that's very clear, like with two people, that becomes even more clear when you talk about two teams or two organizations. As the software scales and your organization changes to support the larger software, this will happen if you're not thinking about it, if you're not aware. This is a very natural, very organic. Mel Conway talks about this as well, and this is where you start to see some of his snark kind of come out. And this is long, so I'm not going to read it to you. I'll let you read it. So it's especially this last sentence that makes me think. This is a 68 version of Snark Classic. The idea is this: if you read this and you read the paper, you hear him start to say, well, the problem to him, or the solution to this problem, isn't, oh, we should be more thoughtful in how we design our organizations or how we handle the correspondences between the organization and the architecture. Instead, he's saying, listen, I've got the software architecture in my head, and if you left me alone and let me do the whole thing, it'd be much better, because then it'd be completely consistent. The minute you have somebody like come in on the project and take it out of my head or I have to explain it, it starts to get bad, right? And where he calls out specifically is the outcome is almost predictable if there's schedule pressure and a budget to be managed. Essentially, once the bosses come in and say, Mel, we gotta get this done, we're gonna have some help, somebody come and help you, everything gets ruined, right? That's essentially what this paper is. The part we don't talk about so much in Conway's Law. So the natural question comes, Harvard has studied it, shown it to be true. We still talk about it because it's anecdotally true. Are we trapped? Like, is this just a trap that we have to accept? Is this like the law of thermodynamics or something like that, a physical law? And the answer is no, of course we're not trapped. This is our brains, right? We can think our way through this stuff. However, it's going to happen. It's going to happen because of our brains. We're looking for these homomorphisms. We have this mirroring hypothesis to deal with, this homomorphic force. So it's probably better to think about this more in terms of sort of jujitsu and using Conway's Law to help us do the right thing instead of trying to fight it to do something that's going to be in contrast with it. We're going to be fighting our own brain. So let's use the jujitsu. And now I'm going to talk a little bit about how I've done that in a few companies now. So that architecture I showed you, that layer cake, that was my own architecture. I was a director at Adobe. I was building a brand new product category for the company. And we'd started as a little prototype project, and the project had viability, so we grew the project and grew quite quickly, and all of a sudden it went from one team owning everything, back end, front end, and client, to now we had multiple teams, and those multiple teams all reported to me. And of course, because this was the obvious thing to do a number of years ago, we built this layer cake. This was our sort of version of the layer cake. All the clients needed consistent business logic. We had a single monolith, Ruby monolith. That was our back end. The core library handled communication with the server. The server ran on top of infrastructure, obviously. So this was our architecture, and so the organization mapped directly to this. And we had a problem with this design. The problem was, anytime one of those clients, we wanted to add a new feature into one of the platforms. Okay, well, that's fairly straightforward. It's following the communication pathways in the organization. Okay, well, that needs, for the clients to talk to it, well, that needs to be implemented in the core. For the core to deal with it, it has to be implemented in the API. If we needed a new database or some other kind of different server, well, the infrastructure team needed to support it. Okay, and each of these teams is kind of doing their own thing, but you have this sort of chain of dependencies, and that very strict chain of dependencies meant, well, okay, all the clients needed to be ready to do it, the core library team needed to be ready to do it, the server team needed to be ready to do it, and the infrastructure team needed to be ready to do it, which meant that, given we had 2-week sprints and we were doing Scrum at the time, this could take up to 2 months to implement a very simple feature. And that was just not working for us. That was just taking way too long. And of course, what would sometimes happen is the core library team would say, well, you know, actually we're doing this other thing, or we're fixing this bug, so we're not going to do this feature yet. And then finally the client teams would say, we're tired of waiting. We know how to make a REST API call, so we'll just do it ourselves. And then they were implementing it in different ways, and different bugs came up. It was not working very well. This was, by the way, this was the Adobe Revel product, which, if you've heard of, it is no longer a product. It was basically Google Photos a few years before Google Photos, and Flickr a few years after Flickr. So somewhere in this time, and I'm getting really frustrated with this problem in my organization, I get a call. I get a call from Sweden, and Spotify calls me. And they start talking about how they do their organization, which it sounds like Huddle's doing something very similar, is using the Spotify model. And one of the things that intrigued me was that they'd recognize this problem. They'd recognize this problem, and they'd built something called feature teams or squads. Does anybody not know? That's actually presumptuous. Does anybody know the Spotify model? Okay, so this is not a talk on Spotify, but I'll give it real quick. Each of these teams is an independent feature team. They own a feature in the product from beginning to end. So they'll have iOS, Android, web, test, backend, data if necessary. It's a full team, and they own everything. It's a full stack team, which means that dependency problem I had in Revel, I didn't have at Spotify. Each of these teams was going as fast as they wanted and shipping fairly constantly. So that problem of speed of delivery, totally gone. It introduced its other problems, but that was solved. And so because of this alone, this was in 2013 or 2012 really that I talked to them. They'd just come up with this, so people weren't aware of it at that point. This alone convinced me I have to move to Sweden to go and work in this way, because what they're doing is so interesting. The thing is, Spotify, would this model work where you have back-end developers across 100 teams implementing things? Would this work with a monolith? No, it really didn't, right? And that was important, because one of the things that Spotify had understood was Conway's Law. And so when they designed their architecture and their organization, they made sure that they were consistent and coherent. You couldn't build the feature team model with a monolith. And they understood that early. So if this was kind of the layer cake I had at Adobe, Spotify basically kind of blew that away. And they had these feature teams that spanned the full stack. There was a light dependency on infrastructure, but a very light dependency on infrastructure, just because virtual machines need to run on physical machines somewhere. And there was a very light dependency on some platform teams whose job it was to package everything up and ship it to the app stores. People would ask me when I was leading at Spotify, what does the Spotify architecture look like? And I was really hard pressed to explain it to them because it kind of looked like this, right? I ran consumer engineering at Spotify. Consumer engineering, we had hundreds of services, and we ran on an infrastructure that was hundreds of services. And so, when I left Spotify in 2016, we had about 800 services running in production. So could I draw you a nice layer cake? I absolutely could not. But that was important because that design would be the only way that feature team model would work well. And so that they understood this correspondence. So they were working with the homomorphic force. And I learned there about how to do this because I'd been struggling to figure it out in my more traditionally structured organization at Adobe. And some of the things I learned, one, be very deliberate, understand any change that you make within your team that affects communication will have an effect on architecture, intended or not. So if you know that, every architecture change you want to make, you've got to make sure the communication model supports it. Otherwise, they will be in conflict. Any communication change you make, and it could be as simple as how you document, it could be how teams meet, that will have an effect, whether you intended to or not, on your architecture. So being very deliberate and just understanding that. Similarly, if you have an architecture you're trying to build, and you've designed your organization supports it, but you maybe have found some bottlenecks. And sometimes those bottlenecks are as simple as like people don't like each other and they don't want to talk to each other. When that happens, that's going to have an architectural implication. That may actually make it harder for you to do the software architecture you're trying to do. And design the organization to design the architecture, right? If you think about it, we don't think about these things at all. We really don't. I mean, we understand Conway's Law, it's 50 years old, blah, 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 blah. There's all these companies doing really interesting organizational models. However, most companies are very traditionally organized because that's what we've always done. And because of that, they end up with software architectures that tend to mirror those communication pathways, or they try and do something different and then have lots of work to do just to make that work, because it ends up being very painful because they're fighting their own entorhinal complexes. This idea of designing the organization to design the architecture, Spotify very much did this. Netflix did this. Amazon did this. This is one of my favorite phrases in technology. This is called the reverse Conway maneuver. And it just sounds so cool when you talk about, yeah, we did a reverse Conway maneuver. Because everyone's like, what? Whoa, that's cool. And as I said, yeah, this is something, this is a pretty good book called Building Microservices. And one of the things he looked at was this fact that microservices are really hard to do in a lot of structures. But Netflix, so Spotify got a lot of these ideas, by the way, from Netflix. We talk to them all the time. Netflix got these ideas from Amazon. And each company is structured in a very different way, but they were all structured in ways that supported this model, and all for the same reason, by the way, scale. So Amazon was designed to scale, Netflix designed to scale, Spotify is designed to scale. Back then, this was before microservices were a common architectural pattern. And part of the reason they were not a common architectural pattern was this problem of correspondence between the organization and the structure. So this book, he talks, it's not about organizational structure, but you have to talk about organizational structure at some level when you're talking about system architectures. And again, the thing I learned trying to build, a very innovative, very fast-moving organization at Adobe. I designed my organization. These strong dependencies, between the systems came from these strongly coupled teams. Coming back to the HBS article, this is their conclusion. We found strong evidence to support the mirroring hypothesis. So what they were specifically looking at as a way of reducing the problem and trying to prove it, believing that the best software architecture is very, very modular. What they tried to see is what kind of organizations produce the most modular architecture, and what they found was very loosely coupled organizations produce the most modular architecture, which was very much proving the mirroring hypothesis and therefore Conway's law. So I've been talking very strictly around software architecture and organization, right? So that's great if all we're building is software architecture, but we're not. We're building products. And so coming from some of the lessons I learned at Spotify and bringing them into my next company, which is called Avo. So when I was here speaking last year at Bifrost, I was at Avo at the time. We sold the company earlier this year. I was talking a little bit about some of the ideas that we had. Oh, sorry. I was talking about some of the ideas that we had around this. So I'm going to give you some ideas about kind of maybe next level reverse Conway maneuver. One of the things that we did later, as my organization grew at Spotify, we realized that we were having a bit of a problem. In that you could see the teams. You could actually see, looking at the Spotify product, I could point at each thing and tell you which were being done by different teams. There wasn't a lot of consistency because they were all working in sort of their own silos. So at the end of my time at Spotify, I reorganized my organization to be more about the product, to be more structured around the product than specifically around the features, because the features were very tied into the software architecture. In a different book, which I wish I'd read earlier, The Organizational Patterns of Agile Software Development, they actually talk about this a little bit. Organizing around product structure as opposed to something else. Again, it's a part of an entorhinal complex mapping, homomorphism. At Avo, when I joined, they'd already started doing something akin to feature teams. I joined as their CTO. But you could do the same thing. At Avo, we called it showing the organizational underwear. You could see our organizational underwear reflected in our product. The edges of our product very much mapped to the edges of our teams, our feature teams. And we had the same problem at Spotify too. So we did something a little bit different. We organized around user journeys instead. So this is taking that kind of to the next level, where you now are thinking about the communication pathways and areas of concern, but as they map to the product, not just to the software architecture. But that's not the only way you could probably do this. One of the organizations at Spotify switched to mapping around different parts of the funnel, your user funnel. You could do dynamic teams if your organization is reasonably sized. You could do that as well. And this tended to produce, by the way, at Avo and at Spotify, much more modular architecture, much more shared code, because now a lot of teams were spanning features and having to touch multiple features in order to follow the user journey. So we went from something like this, which was Revel, to something like this, which was Spotify, to something like this, which was how we did this at Avo. So now you have a much more overlap between teams. They're all kind of doing their thing in communication pathways are being reflected in the product, but they're being reflected in the product, not just in the system architecture. And the product is mirroring where the user's going, as opposed to where the developers happen to be working. I'll give you a little bit more background on this Conway Jujitsu that we did at Avo. So before I joined, like any startup, it was one team. It was one team building a monolith, because that's what you did in 2004. And everything was great. And this monolith was getting bigger and bigger and bigger, but it was okay because it was one team, so everybody knew it. And eventually, new developers, companies growing, new developers come in, and it takes a day to ship to the monolith, and and it's like all the spaghetti code, and the new developers say, yeah, maybe what we'll do is we'll just put a little service off to the side, and it'll call the monolith, and then that way we can ship faster. So then eventually we had a bunch of little services kind of sitting around the monolith, and at some point somebody had said, yeah, we really need to break this monolith up, like most companies will eventually say. But now it's a problem. It's been in development for 10 years. It's got like all the code in the world in it. And so they really struggled, especially because the newer teams had built their own little services that they were very happy to work on. And then there was one team that was just stuck maintaining the monolith, and they could get nothing done because it took a day to ship it. So one of the first things I did, understanding this problem, was I moved us to full stack teams where everyone had a piece of the monolith. And this is in direct conflict with Conway's Law. I broke up the way that the correspondences were, specifically because I wanted to create pain. And this is not something you hear leaders say very often, but if one team is stuck trying to break up the monolith and they can't, and everyone else is very happy to go off and do what they want to do because they can do it at will, well, what's the best way to break up the monolith? Make everybody responsible for it. So what started to happen is teams started to say, oh, we can't get anything shipped because we have to touch the monolith. So, okay, we're going to just slice this thing off and we'll put it here, just so then we don't have to deal with that part of the monolith anymore. And what started to happen is we started to finally make progress breaking up the monolith, because I took advantage of Conway's Law and I made things difficult for people. Sometimes you have to do that. Similarly, we had a problem where we had data. We had a data team, data engineering team that was separate from product engineering. And we had this problem because Conway's Law, product engineering kept breaking data engineering. They kept breaking the pipelines because nobody was paying attention to them because they're over there and we're over here. So what I did, we didn't have enough data engineering people. So I hired more and then I put them into the teams. Now there is no data engineering team. We're all data engineering. All the teams have data engineering in them. This created a problem because the data engineering pipelines, that was sort of its own kind of monolith. This also forced us to modularize our data engineering infrastructure, and then we stopped breaking data engineering. So that was, again, taking advantage of Conway. In another area, we created a silo. We created where there hadn't been. They'd been trying to do iOS, a mobile team, spread around a little bit. But the problem was at that company at that time, we didn't really have a good mobile strategy. So having mobile team kind of distributed meant the communication pathways were all kind of broken up, and we needed to have that team moving much faster. So I brought that together and made a mobile team just focus on solving the mobile problem, and then once we had a better mobile strategy, we could redistribute. And then we moved into this journey team model. So that was at a company that's 400 employees, 10 years old. That was kind of how we handled it there. Today, I'm at an early stage startup. I'm at the very beginning, so I'm designing my organization and my architecture from scratch. So this is how we're doing it in this environment. So we're starting from microservice architecture. It would be so much easier to start building a monolith. It would save us a lot of time. We spend a lot of time building infrastructure, but the answer is that would be great up until we had two teams, and then that wouldn't be good so good anymore. So no, we're taking that hit now because we're growing and we're expecting to continue to grow, so that we're giving ourselves the most amount of freedom so that organizationally, as we grow, we'll have a lot more choice. We're also starting with a much more modular code base. In our case now, we're a node shop. So we're doing everything in modules and our own NPM and distributing things that way. So all that stuff is shared, which will make it much easier for us to have multiple teams sharing the same code base. We're dealing with the tension. This is creating tension. We have, instead of one team, one code base, we have one team and like 20 code bases. It's a problem. It's a problem with our it's behind your eyes. It's a problem with our homomorphic, it's a homomorphic mapping problem. It's a problem for our entorhinal complexes, but we're dealing with it for now because we're not thinking about today, we're thinking about next year and the year after, and I'd rather create that pain now than try and deal with that pain when I have a much bigger organization in a couple years from now. So, actually oh no, I'm over time. I just want to sum up real quick. Conway's law, or the homomorphic force, or the mirroring hypothesis, however you want to call it, it's going to happen. This will happen. And it's going to happen because of your entorhinal complex and your hippocampus. It's going to happen because of your brain. And it's too hard to fight your brain, so just go with it. Do your Conway Jujitsu. And leverage it. Take advantage of it, but be aware, be deliberate, and understand the implications of the decisions you're making, both on your architecture and on your organization. I am over time. I'm around. Oh, I can do a few minutes for questions. I'm here through Friday, but if you have other questions, you can feel free to tweet them at me. Yeah.
My question is that during your first example, while you keep growing the team and make it more cross different stacks, from then backend data and eventually iOS.
Yeah.
To the individual team members, how do you balance the effects that everyone has to know all those layers to be part of the team?
You don't have to know all those layers. So people still have their specializations, right? So what I actually did, so I'm a strong believer in T-shaped people, and you have a diverse set of skills represented in a team, but I don't expect everyone to do everything. I expect people have a full stack developer. Some prefer the front end, some prefer the back end, some want to do more machine learning. That's cool. Let's support that. So that's how you do it. Isn't that everyone is now responsible for data engineering? It's literally, I hired somebody that is a data engineer, and that person is now on your team instead of on some other team on a different floor. So yeah, I'm not saying like we train everybody in everything. It's more that we make sure those skills are represented in the team so that they can own it. And at Spotify, where I really kind of saw this work real well, that there's a trade-off there. There's a trade-off around efficiency. Spotify squads, massively overstaffed relative to like other companies where you have functional silos. But that's part of the trade-off you make for organizational agility, high bandwidth, high velocity innovation. That's a choice you make. Yeah.
Oh, hi. How do companies with multiple geographical locations factor into your thinking?
So almost every team I've managed, actually every team I've managed in the examples I gave was distributed. So at Adobe, my team was spread over, I think, 5 geographies plus individuals in different places. At Spotify, 4 offices. Currently, even at Avo, actually Avo we were co-located, but at Astromu we have 2 different locations. So this works fine. Distributed teams are distributed teams, no matter how you do this. That's more within how the team works than the multiple geographies. What I will say is at Spotify, we tried to keep teams geographically co-located. But the organization itself was each tribe was spread over multiple spots. Yeah.
Do you teach your staff so they understand what's going on before you start reorganizing, or is it just the evil guy in the back room?
It's kind of the evil
pieces?
guy in the back room. I think some of them
What works best?
some of them may
Doing
watch this talk and go, oh, because they certainly weren't necessarily happy about some of these decisions earlier on. In general, like I will try and be transparent about them, about these decisions, and certainly I don't do them. I don't just make a decision and now it's done. It's a conversation. It's always a conversation with some part of the organization. So I don't do a lot by fiat. So there's usually a lot of discussion around it. So people within the organization are aware and that these are the considerations. But yeah, I'm not sure how great the communication got out. This is why we're doing some of these things. But it did work. So, But it was a little painful for a while. But if I told people in advance, hey, I'm going to make your lives really hard for a few months and make it really hard to ship so that you'll do what you need to do, what we need to do as an organization, I'm not 100% sure they all would have signed up for that.
For teams that are involved with, so they're working through the stack, but then let's say there's a front end team within that stack and they are trying to make an organizational change where they're trying to change like a framework or something like that.
Sure.
How does that work across, because they probably need to get together to kind of figure out how is this going to work, and then they're going to have things outside of their team.
Oh, so when you're talking about like functional specialty, right, front end, like JavaScript or something, is spread across multiple teams, how do they make an architectural decision that affects all of them?
Yeah, exactly.
Spotify created something for this called guilds. So every front-end developer at Spotify was a member of the front-end guild. And the front-end guild would talk about software, talk about some of these choices. What I will tell you, though, certainly when I joined Spotify, and 3 years later, this was better, but not solved. At one point, Spotify was shipping, I think, 3 different versions of jQuery just within the desktop app, because different teams were using different versions. And by the way, it was also shipping, I think we had Angular, we had a bunch of different stuff, because different teams were making different technical decisions and architectural decisions. Eventually, the JavaScript guild decided this is not a good idea, like we should fix this, and they came to consensus as a group. I did a similar thing at Avo. I didn't create guilds necessarily. The company was smaller. There was much easier ways. But the folks who were primarily building JavaScript would meet, and they would come together to make decisions. Even at Avo, which was a much smaller company, we were using React plus Vue plus Angular plus jQuery just because of how stuff happened. There are ways to handle this, but an important part when you have these silos is to find ways to encourage people to get through them that are functional, that are working on the same area of functionality or same functional skill sets. The guild model is a pretty good way to do it. Wow. Boom. Blew the power.
Sure, but one more question.
One more question.
You may have answered this with the previous answer, but any wisdom you can share on hybrid models of what you presented? For example, having functional teams, but also some team that's cross-functional.
I think that, so I have done the hybrid model. I talked about that a little bit at Avo. You can do, don't copy Spotify, don't copy Avo, don't copy whatever I do at AstroMu. I'm gonna hopefully come back and tell people about it at some point. Don't copy it, right? Take those ideas. I would say coming from an understanding of this interaction, this homomorphism, when you decide how you want to structure your organization, understand the architectural implications, right? So if you want to have a functional team, either for resourcing or for some other reason. In my case, it was like, well, we need to move fast and figure out a mobile strategy, right? And it's too hard to do that if the team is distributed functionally. Just be aware of the implications of that decision. And you can do any kind of structure at all if you understand. So you can't be surprised if you split off one part of your back end into a separate function, that they go off and they just build stuff for themselves that makes sense for them but doesn't make sense for the rest of the organization and your larger software architecture vision.
I definitely just want to be underwear.
Yeah.
All right, thanks, Kevin.
So